Okay, now let's see how the uh, figures of the polynomials look like in MATLAB. Now before going there, okay, you have seen this way to write a function in MATLAB. There is another way to create a function using the symbolic variable. Okay, sim6. Okay, so the idea is very simple. Use the symbolic math toolbox. If you define the variable as a symbolic variable, then you can write a function like this: f of x equals to, say for example, x square plus 3x plus 2. 3x plus 2. So that means the function, this is the output y, is defined as a function of x. If you find a value, say for example f of 3, so what will be the 3 becomes 339, 339 plus 2, that is 20. Okay, it works like this way, very simple. So let's use this one first for quick option of writing a function. Okay, later we discuss the difference between these two, when to use which. Okay, so first we define a variable, say sims x. Okay, we define the variable x, the symbolic variable. Okay, now let's write a function. So let's write f1 of x is equals to 5 into x plus 8. Okay, let's define another function, f2 of x is equals to, now let's change the slope from 5, let's make it 10. 10 into x, okay, plus 8, let's keep the same. So I have two functions defined. Okay, now what I want to do to create a plot, the plot function takes the input variable x and the corresponding variable y. That means if you take a plot like this, for value of x, what is the value of y? For another value of x, what is the value of y, like this? For another value, what is the value of y, like this? Okay, you have to define the set of value of x using an array. Also define the set of value of y using an array. Then it will automatically connect the line. So let's create the x-axis point. Okay, let's name it, let's do it like this way, from -10 is to 10. Okay, so this is my a. So this is my a. This is defined. Okay, I have total 21 points now. So what is my y1 is equals to f1 of a. This is my y1, f1 of a. That means for all of this point, it is going to calculate the point. Similarly, y2 is equals to f2 of a. For all the points of a, this is going to calculate this portions of y, these values of y. So we have y1 and y2. Okay, now let's plot a comma y1. Okay, then hold on, then plot a comma y2. Okay, let's read on. Okay, let's see. So as you can see, you can also put the legend. It's okay, fine. Okay, so update code. So if you click on the update code, it is automatically come here, legend show. So as you can see, first what we did, for the values of a, these values, y1 is the values from first function, that is 5x plus 8. y2 are the values from calculated from second function, that is f2 of x. So I first plot the first function, data 1 is the green line, so this is the data 1. Then I created hold on, that means I want to plot in the same figure. Okay, then plot a comma y2 on the same points. I want to plot the y2 value, that is data 2. As you can see, this is 5, this is a smaller slope, this is 10, that means this is a higher slope. So the curve is different, but the cross point, the y point axis, is actually the same. Okay, and then grid on and then show. So I hope it is clear how to create a plot. Now this is a simple linear equation, okay, linear curve. Let's go to non-linear curve, like a quadratic formula. So in a quadratic formula, we see the formula looks like this: y is equals to ax square plus bx plus c. This is the general formula of quadratic equation. So let's create similar function like this. This was f1, f2. Okay, so let's define f3 of x is equals to 3 into x square, 3x square plus 5x plus 6. Okay, just arbitrarily. Let's create f4 of x. Okay, actually let's plot one first. Then y3 is equals to f3 of a for the same points. Okay, for the same points I am calculating the y3 directly. Then I want to plot for a value, I want to plot the values of y3. Okay, and let's keep the grid on. Okay, first I have to write hold off. Now let's create here. So as you can see, so this is the curve of this equation. For this equation, okay, we get this curve. Now let's tweak a little bit more. Okay, let's keep everything same. Let's change a little bit. Let's first name it f4 of x. Okay, and just put a minus sign here, and let's see how does it look like. This is f4 of a, this is y4, and I want to plot a comma y4. Okay, everything same, the equation is same, only just instead of using ax square, I just used minus ax square. That means the coefficient is actually a negative number. Okay, let's see how it impacts our curve. As you can see, the curve completely 180-degree shift. Okay, it was some like this has a valley, and now it has a peak. Okay, so this coefficient means when you have a greater than 0, then I have a curve like this. When you have a less than 0, okay, I have a curve like this. Okay, similarly, if you change the value of b or c, you will see it is going like this. From like this, it is going like this. Okay, you can change the size by changing these parameters. Okay, by changing these parameters, you can try it by yourself. Okay, so similarly for higher order, if I want to create some higher order, yes, something like this, let's add some more parameters here. Minus 10 into x to the power 6 plus 9 into x to the power 4. See here, I didn't put any x to the power 5. That means, what does that mean? When I'm writing like this, x to the power 6, something 7x to the power 6 plus, didn't write anything here. I just write say 6x to the power 4. So what is the coefficient of x to the power 5 that I didn't write, and dot dot dot. This means that here I have x to the power 5. I have x to the power 5, but it has a coefficient of 0. That's why it is not there. Okay, remember this thing, it will be needed a little bit later. So let's see, everything is same. Okay, now let's see the output. Okay, as you can see, the curve is now like this. Okay, this is not a curve like this. This is also have one peak, or you can say a straightforward line. Okay, so if you tweak this equation, you will see different curve is appearing. Okay, so for different equation, different curve will appear. Now let me give you another example here. X cube minus x square minus x square minus x minus 10. Okay, now let's see. Okay, as you can see, now we have something like this. The curve shape is a little bit different than others. It is like this. Okay, so if you change the value, it will be like this. So when it is like this, if you increase the range of a, let's increase the range of a is equals to minus 1000 is to plus 1000. Okay, we can see a larger shape. Okay. So as you can see, the shape is like this. This is the shape of the curve. So this is one valley that we have. This is one peak that we have. Okay. So for different equation, the curve shape will change. Okay. So I think you can create it by this way. Now, one other thing is that, so when we are creating a function like this using this symbolic function, okay, what is the difference with creating a function like this way instead of this? So for when you want to create a function like this quick function, this is a very suitable approach. But say for example, if you look here like this, so this is another function that is defined. As you can see, this has different steps. Steps means when I want to debug my problem, when I am writing a code, I want to debug. Okay, you should write a function like this way, because when you are writing like this way, you cannot see what is the output of individual step. But if you write a function like this way, you can just omit this semicolon and you can see the output, what is the output you are getting from this line. This way it is actually much more easier to debug a problem, so where your function is not working, and you will face it lots of time when you are trying to work in a real life example. So when you are trying to write a very fast function, you can create it like this way using a symbolic function. Otherwise, try to write it this way. Okay. Now one last thing is you have seen we have already created a function for one variable. You can also do it for two variables. Okay. So for example, I can define a function sims like a comma b. Let's a b different. That means now I have two different variables, symbolic variable a and b. Okay. Now we can define a function of a comma b is equals to, say, a square plus b. Okay, this is the function. Let's run it. So my function is created. Okay, this is my function a square b. So if I write f of 12 comma 2, then it is like, no, let's make it 2 comma 3. Okay. 2 দুগুণে 4, 4 আর 3 7. So f of 2 comma 3 should give you 7. Okay, so as it's 7. So you can actually define multiple symbolic variable at the same time. So I hope it is clear. In the next, we'll actually look more into polynomials.